So as said, I'm Laure Lebas. I work for SAP. I'm a research project director here, and I'm also the president of this European Association of Industry in Quantum Technologies. And this is where I first met you, Enrique, yes. More than 3 years ago when we set up this quick. So first through a video conference where we started during the first lockdown, and then in a real 3D, etc. But before we start and talk about this, can you tell me more about you? Who is Enrique?
Thank you, Laure. Well, Enrique is the CEO and co-founder of Multiverse Computing. I am a mathematician myself, and I have some other degrees. But I'm just the CEO of the company. My co-founders usually, which are the people from physics, they don't let me just speak about quantum, just because they fear that I might make a mistake. This is by large the fastest and largest company that I have found, and we will talk about that later.
Yeah, so I think we have, I don't know how much you know about quantum computing, but we first have to explain what is quantum computing. I'm the same way. I'm a mathematician and a software developer as a background, and I get interested in those topics recently. Mm-hmm. So could you tell us about it?
I will try. I will try, definitely. From time to time, I don't know whether this is working somehow. Okay.
Sometimes the drawing is...
yes, people there, okay, has told me that I have to wait. So 1 and 2, yes, that works. So the most important, I mean, explaining quantum physics, quantum mechanics, and so is complicated. People usually say this is too complex to understand. People that the things that understand quantum mechanics, they don't really know, and so on. So I usually use this nice slide from our friends at another company, Zapata, and explains how fast it is to break an RSA, which is a cryptographic system. With a traditional traditional computer, the one that we have today, a supercomputer and so on, okay, they say I don't know how many trillion years, that's all. And with a quantum computer, okay, this is the other one, okay, just 8 hours. So this is the power. Okay, but problem is that we don't have fully fledged quantum computers as now. Okay, we are always saying that probably we will have in the 5 years and so on. So what we do have now, and then we have to think, and this is important from the point of view of a software company, that quantum computing is just a race of 2 horses. On one hand, a quantum computer improving, and every time that a quantum computer improves and says, okay, we are doing something that you cannot do with a regular computer, then you have the classical methods running in your computers, and those are quantum-inspired methods, which are the most powerful classical methods, and they compare it and say, oh, not yet, because we have improved, and then the quantum accelerates, and the other, and so on. So these 2 horses are playing along during this transition period. On the long term, quantum will win, probably, will win, sorry. But in the meanwhile, those are the 2 main things that we have.
Yeah, so, and this was part of my title. So this is a different approach, mainly, and this is really the way we should see it, not saying that just more powerful, but it's another way of doing computing. So could you go deeper? How is it interesting for AI or optimization?
Yes, those are the two methods that we use, either quantum and or quantum-inspired methods. But the point and the question is quite relevant. Okay, what happened to quantum and AI? Why this field is extremely hot right now? Okay, because basically quantum computers and the quantum-inspired methods are very good at determining the correlations that matter inside the data. So, for example, examples from our customers that maybe, for example, Acciona or Bosch or whatever, I mean, you can train an AI system much faster, which is important because it costs a lot, or with less data, which is also important given that some particularly continents, or like Europe, lacks the amounts of data of some other of some other, let's say, in America or China, and so on. So this is an example. Either speed, either less data just to train, but those are important things to know.
So you have, I mean, those quantum and tensor network. What do you concretely propose to your customer? I mean, what are the solutions?
Yes, in fact, for example, you have here some of the names of customers. You can see that those methods you can apply everywhere. I mean, 40% of our customers usually ask for pure quantum methods, and 90% you can see that there is an overlap. Also prefer to use quantum inspired because they can use right now. Okay, but the question is quite relevant. I will put some example because you can see here a lot from healthcare, manufacturing, I mean, finance. But there is one thing that will just set what's happening there in this field, and you will understand why it's important. And this is particularly one thing that is the compressing the large language model. Large language models, as you already know, is ChatGPT or those kind of things, llamados, etc., etc. This is super good. I think that everybody here has just tested that, and probably you are using in your job, whether it is approved or not. Okay, but the point is, well, you need a lot of money just to train a model. Okay, there are just charts over internet stating that you need $100 million just to train ChatGPT 4 or something like that, and this is scaling. This is doubling I think, these 10 months or so on. The point is, can you just look at LLM or any other machine learning system with a different set of eyes, with the eyes of a quantum computer? Yes, you can. So if you do that with tensor networks, the structure of the LLMs are different. You can see, you can understand where the information is there, and then you can compress that. And this is important. How much can you compress? Over the traditional techniques, you can compress to 93%, 95%, 96%, or even more. That means that Llama 2, which is a large language model of 7 billion parameters or 70 billion parameters, you can reduce just to a small 5%. And that brings tremendous consequences. Tremendous consequences. First of all, retraining time is half or more, or less, sorry. And that means if you do the math, either 100, either to 50 millions. Second, I mean, running time, inference time also is slashed by half, because you have just slashed out a large part of the language model. And this is important for some customers. If you want to put, and those are real projects, compress LLM in a car, you can do. If you want to run with fewer costs, okay, you can do that, and those are large amount of money. And in the last case, if the model is small enough, you can put in on-prem. Because there are some customers that don't want just some other companies, especially from some other continents, to mess with the data. This is what is called AI sovereignty. Okay, so can you do that with quantum-inspired methods? Yes, you can. This is important. This is, as you can see, this is right now. Can you do that in the future with a quantum computer? Yes, yes. So is necessary something which is called quantum supremacy to do that? No. Does it matter, really? No. From the point of view of a software company, it doesn't matter. The only thing that matters is how expensive it is.
Yeah. And could you go back one slide, because you showed
yes,
different...
I will try. Yes.
He has the power. You have, so we show finance, manufacturing, etc. So more or less cover all type. I'm more interested in energy and
yes.
How could it help for the green transition, for
example?
Yes,
I mean, the example I talked about before, which is the compressing the LLM models, is a very good one. I mean, before we were just having some remarks about some super large American company with particular goals about carbon footprint from the previous year. And this year, those goals has trashed, because we are just spending, let's say, indecent amount of energy. For example, Ireland, I think that they spent 20% of their energy in data centers in last year, but they plan to spend 36% in 2 years. So we are just having new regulation. Okay, we have two options here. One of them is quite easy. Let's stop teaching maths at school. So if we don't know how to compute, we don't have a problem with that. I think this is already happening now. Okay, second one. If we want to go on just teaching maths at school, okay, let's try to find some way just to compute more efficiently. Okay, this is one way. This is a super way. Okay, and this is nothing compared to what is going to happen when we transfer those methods from today that we are just running and selling just today in the future to quantum computers. Wait and see what is going to happen. I don't know whether it's going to be good or bad, but this is going to be different for sure.
Yeah, and on the other hand, I mean, working in this, it's relatively new for me as well, and you can hear some saying, yeah, but quantum computer will never work, or if it's, I mean, it's not ready yet, it's not reliable. What do you say to that, or what can you offer now?
Yes, this is I think that the question should be put into the right context. I mean, can we just, let's say, accept that we are not going to develop this kind of techniques that are going to change the world? Okay, this is, can we afford forgetting about that, knowing that we do know how the algorithms are, which are the ones that are going to run in the short term that we are already running, and in the long term. Okay, this is also a kind of existential threat. Okay, I mean, in other way, if we don't do that, probably we can also name that as technological colonialism. That could be, I mean, quite strong, but this is the case. So those techniques, this is like, let's say, knowing how to add, how to subtract, how to multiply. I mean, this is the basic thing of the things to come. So either we have the control on that, or either some other people are going to do. We can choose.
Yeah, and that's something important to remember, I think. Again, this is not just having a more powerful computer that will replace it all. No, it's good for certain type of problem. I mean, we mentioned different type of AI optimization will be a good complement of what we do today. And so it's a different approach, and it's a different way of solving, and we have to find this combination. And this is booming and blooming as well area. And so I mentioned earlier this European Association of Quantum Technologies. So you are my dear treasurer, I'm the president. But as a startup, what does it bring to you being part of this?
This is super important. I mean, we cannot fight this fight alone. I mean, this is too serious. I mean, we are developing things. This is deep tech. Sorry, this is deep tech. This is deep tech that is going to affect all not only the technical part, the companies and so on, but also the society itself. Okay, and we must have the levers, I mean, and the ways just to influence, which is the environment and which is the position of the largest organizations and institutions in Europe. Okay? This is not lobbying, this is just an association, but we must do that. If not, on our own, one by one, we are not going to be able to do that. So, associating in a large institution like that, like the European Quantum Industry Consortium, I think that we are now more than 180 companies there. This is a way to say, hey, Europe, we want to do that. Those guys are doing differently than us. So we have to improve, we have to support, and particularly we have to support our startup ecosystems. And this is a big difference with the rest of the, let's say, of the parts of the world, with China, with the United States. We do have talent in Europe. Yes, we do. No doubt about that. We do have startups in Europe, small startups. No doubt about that. But we don't have scale-ups, for example. And we have just to find the way just to put the resources inside there. And this is not, those are not free resources, those are investment. Those are not grants, those are equity. And why don't we don't have that? I don't know. It doesn't matter. The point is, in the realm of quantum, 6 months is an eternity. Things change a lot. In the realm of AI, 2 months, okay, is even worse. It's the difference between ChatGPT 4 and ChatGPT 4.0. So either we act fast and put remedies to that situation, either we are going to fail again. So having an association like the European Quantum Association here, just to get us all together, try to influence the politics, the financial politics, and also the innovation politics inside the European Union. And also put in the instruments that we need as a startup. This is really important. This has not happened in other realms, but it's happening in quantum. And that's something that we have just to take advantage to have.
Yeah.
So join if you are working in quantum.
And I think this networking aspect is important. I mean, of course, the ecosystem, and it's not just about meeting investors, etc. It's really about all the ecosystems. We talk about all quantum technologies, so all enabling technologies, sensor, etc., up to quantum computing. And as you mentioned, we also speak one voice as industry towards the European Commission, towards national, trying to influence the politics, because this is one of the technology of the future. And so going back to you as Multiverse, so you expanded, so you're based in Spain, San Sebastian, you're expanded in Munich, Paris, London, North America. What's the next step? What's
Okay, this is a pretty good question, and this is the most difficult question always. But this is a real thing. Look, in the realm of quantum AI, this is a very new field. But remember, I mean, just McKinsey showed 1 week or 2 weeks ago, they released a report when they say, okay, quantum computing, this is going to be about $2.2 trillion of impact. AI, generative AI, this is has an impact of $4.4 trillion. This is double. But quantum AI, I mean, the sum of the parts is even larger. 1 plus 1 is not 2, it's more than 2. So this is important. So which is the goal exactly? I think that we are the largest one in the world in this field. I mean, there is another large company in US that states also in quantum AI, but they are doing basically some other thing, which is post-quantum, is just adequating the telecommunication. So I want to remain there. So we have to grow a lot. We have just to double the revenues. This is something that is not this company alone. The investors won't just, they want this kind of multiplier and so on. And we want to remain that. So in this position, you have not seen nothing yet. You have seen nothing yet. It's not about compressing the models. It's about applying to different ways. It's about also to make the models forget about information. And if you want to get dirty, it's about injecting information to the models, which is even, the future is bright.
Yeah. Any wish, number one wish you will have?
Yes, the number one wish is just to have exactly the same resources as some competitors overseas and so on. And just doubling our size in the following 24 months, okay? And establishing our footprint in some other continents as well.
And I think it's very attracting, as intellectually challenging as well. This is also what is interesting. It's not just about doubling the revenue, but it's also making new ways or new way of thinking.
Look, we are changing the ways. I mean, I was talking before. I mean, we will remember the date of the month that when ChatGPT appeared. I mean, the world has changed. The world has changed a lot, and it's going to change even more. So this is working on the edge on this kind of technologies, oh, no, boys, this is not even about money. This is not even about power. This is about just working in a sci-fi book, if you want to. You are dealing with problems and solutions that we have never imagined. Those kind of things that I have explained to you, I mean, 3 years ago, they didn't exist. 2 years ago, some of them, they didn't exist. Some of them, 1 year ago, they didn't exist. And now we are just looking at that. And the next years are going exactly like that. So this is to have the ride of our lives. I thought I would, I hope.
Yeah, no, I think we have, the limit is the imagination, I will say. So maybe I think we still have time for question, or is there anything you would like to add before?
Yes, we have some question here. So yes, I think that we need the stick.
Is it on? Yes, it is. Hi. So, a couple of things. One, I loved your 1 + 1 = 2. I feel like you missed the joke that right now quantum doesn't necessarily mean the 1 + 1 = 2, but it will. Like, I'm excited about it. Also, with sci-fi, the fact we're on Isaac Asimov Square, like, perfect. One of the things that you mentioned, like everything you covered in there, absolutely amazing. Very excited about it, and I agree. The one that I did have a question around is to do with the amount of training data, therefore the parameters that you'd need for a model, because one of the things which mathematically isn't properly yet understood is the double descent issue, right? So with large language models, they become more accurate when you give them like insane numbers of parameters. So rather than becoming overfitting, they become slightly better, and we don't really understand why, and that seems to be a consequence of the huge amount of training data. And you mentioned within there that you think you could, like quantum will get around that need for training data while still not ending up with overfitting. So I'm intrigued to hear about that.
Yes. So regarding the compression, all of these kind of techniques and so on, once you tensorize the model, I mean, you can select, particularly there's a middle step, which is the analysis of the layers of that. So you can select which is the level of compression of the different layers at this moment, and which are the ones that you want. So now, the path diverges. On one hand, okay, you may go on just compressing the models directly and so on. And after that, you have a decay on the compression or on the accuracy of the models. So you may have to do a healing up, which is that means a very short retraining with a partial data. Okay, this is one thing, and you can do that today. On the second hand, okay, even from the theoretical point of view, there is an optimal way to compress without loss of accuracy. This is an optimization problem as well. So you have to mix that with some solution from particularly the optimization algorithms that we have. And this is the way that you do that. As a bonus, okay, given that you have already understand which is the structure of the different layers, which is how much can you compress each layer, and by the way, this is a recurring problem, because once you compress one, then the ways to compress the other ones change. So this is in itself is also okay, as a bonus, you know, depending on the test that you you may do, where the information lies. And then you may decide to erase some information. Why is this important? Because you already know that the models can be tricked, as today, just to reveal the secrets and so on. So maybe you are interested particularly in erasing some concepts, which is important, not just sentences, words, or something like that. No, it's about concepts, which is a more difficult thing. That we can do as today. What we cannot do so far, but will be the next step, was about just erasing some other things that are not concepts, like, for example, the problems with music and those kind of things. Awesome. I hope that this has some sense.
So just to summarize that, to answer the the question to do with the amount of training data, it's basically being more intelligent in the way you actually select the data and then improve the algorithms, which actually then you use within quantum modeling.
No, but this is, sorry, I didn't get.
Because
can you elaborate?
So I agreed with everything you said, but I don't feel like it actually answered the key question, which is to do with the double dipping question around particularly extra large language models, where the more data you throw into it, and that's not to do with compression, it's to do with the sheer amount of data it's trained on, you end up with less overfitting. No one really understands that yet. Mathematically, we don't know why yet. And I don't see a reason that quantum computing would solve that issue. It solves everything else that you've mentioned. Like, I agree with that.
Oh.
I don't see how it solves that issue to do with the amount of training data that you need to give it to now allow it to train. I agree that it's more efficient to then train on that data, but I don't see how it reduces the amount of data that you need to end up triggering the...
No, but we are not training the full model at this time. We are getting a model that is already pre-trained. Okay.
Yes, but you mentioned during your talk that it would also, so as you said, within
Yes.
Europe, one of our issues is that we don't have access to the huge data sets that companies like Google or X or Meta have, right? And so you were suggesting that becomes less of a problem with quantum. And that's the question I'm asking. Does the question make sense?
I don't know what is the question. I understanding quite well your question.
Everything you said was correct. It just doesn't.
Yes, the point is we are compressing models that are already prepared. Okay.
Yes,
So
I
this is
understand
the
that.
thing.
I was referring to an earlier.
Second thing, you are compressing and we are reducing the number of parameters. Okay.
Yes, and it's going to be amazing for that.
And from this one, I mean, but you are reducing the number of parameters, knowing what those parameters mean, which is not a blind pruning, which is the traditional technique. And that means that the retraining on that is more efficient, basically because you have reduced the number of parameters a lot.
Yes, I understand that.
And this is without the quantum computer.
Yes, I understand all that.
Yeah, we could do
If not, we can
hours on this.
we can talk
It's
later.
okay, thank you.
That's too short. But that gives you an idea of the field of potential, etc. And again, this is a bright future. And I think we should... do we have time? No, I don't think we have time for more questions.
If we got time for...
Okay, just one.
Okay, thank you very much. I'm going to be short. I tried. Stan Altman said 2 months ago that if we invest in LLMs, in AI, it's going to be worth it, no? 500 millions, 5 billions in a year, because we are going to move forward to the AI. He thinks it's interesting, and I think quantum computing is the same. I think it's a powerful technology. So what is the real problem in just one short answer? Is money, is ecosystem, is talent? Why we have no access yet, and when is going to be quantum computing be accessible for people and companies? When do you want?
It is pure quantum computing, I assume, you are talking, and pure quantum computers. Okay, those are already accessible. I mean, you can access through the cloud, some of them. I mean, particularly IBM has a System 1 and System 2, different ways. You can access also to, for example,
Euro HPC,
the
European Commission is installing stuff, so you have access to it. And that's this hybrid architecture, which is also good because you can test this mix of HPC and quantum. So there are plenty of ways to test it, and yeah, I mean, you as a company or us as well as SAP, we look from a software point of view. I mean, it's at some point. For now, we do some testing, but one day we need the one that works in every case and that is really agnostic. But there are plenty of possibilities, and in terms of providers, so there are the big names, of course, but there are also plenty of European startups as well that propose the hardware part, and that's
yes, you can do
blooming.
That. If the question is when you are going to have a full-fledged quantum computer, which is a different question, and maybe this is also you. I mean, I don't know when it's going to happen, but look, according to the French, I mean, they give 500 millions, expecting something in return for 2030. So I hope that they are going to reclaim.
We will have more and more application progressively. So anyway, thank you, Enrique. So there's a
Thank you very much.